3, I can determine whether a graph is misleading. So these two graphs, for example, 1 show the same exact data. It says the line graph shows monthly profits of a company from October to March. Which graph suggests that the business is extremely profitable? Is this a valid conclusion? Explain. So graph number 1 looks like the profit of this business is increasing a ton over time. This one looks like it's barely increasing. It's still increasing, but not as quickly. And the thing is, these two graphs represent the same exact information. The difference is this one they skipped a bunch of numbers and it started the y-axis at $14,000 profit and then went up by 500 and then 500 and then 100 and then 100 and then 100 and then 100. So this part of the graph where it looks like it's increasing a lot, it's really only increasing by 100 right here and by 300 right here. But because they changed the scale, it looks like it's increasing a ton. This one has the same information, but they go by 500s the entire time. So the first graph makes it look like the company's extremely profitable, but it's not a valid conclusion because they didn't use the same scale. So we would say the conclusion is not valid because the scale does not use even intervals. Okay, the second one says an amusement park boasts that the average height of the roller coaster is 170 feet. Explain how this might be misleading. So we're going to look at the average of the data a little bit more closely. So the mathematical average usually means the mean. So we would add up all the data and then divide by the number of data points. So we would add up 109, I'll get my calculator. I would add up all of these digits or values and divide by 1, 2, 3, 4, 5 because there are 5 values. So 109 plus 135 plus 115 plus 365 plus 126 and then divide by 5. So the mean when we add it all up is 170, just like they got. Another way to measure the center of the data though is the median. So let's find the median of this set of data. So the lowest data point is 109 feet. The second lowest one is 115. And then next is 126. And then 135 is next. And then 365. So we're going to find the median. That's the middle number. So I'll cross off this one and this one. So on this one, the median is 126. On this one, there's no mode because there's no repeated data. And it says, why is the mean so much higher than the median? Which one's more appropriate to use? So the mean was 170. The median is only 126. The reason the mean is so high on this one is because we have this outlier here. The tornado is 365 feet tall. That outlier is bringing our mean way higher. So it's going to be more appropriate to use the median because we have an outlier. So why is the mean so much higher than the median? And that's because the tornado's height is an outlier. Tornado's height is an outlier. So which one is more appropriate to use? The median is more appropriate, and it better represents our data. Example 3 says, the table lists the 5 largest land vehicle tunnels in the United States. Convince your neighbor which measure of center you would use to emphasize the average length of tunnels. So this is one you're going to do on your own. You're going to decide, would it be better to use the mean or the median, and why? If we wanted to emphasize how long the tunnels are and show that our tunnels are very long, which one would be better to use? Example 4 is use the graph below to answer the following questions. Who had the most career wins by pitcher? Definitely Cy Young, I can see from the graph. It appears Cy Young had about 3 times as many wins as Jim Galvin. Is this a valid conclusion? Well, Cy Young had about maybe 525. Jim Galvin had about 375, so is it 3 times as many? No. And why did that happen? It's because they didn't start at 0. They started at 350. And maybe they started at 300 if we go back an interval, but the conclusion is not valid because they did not start at 0. This is Example 5 says Janet kept track of the minutes she used on her cell phone for 2 months. How many minutes did Janet use in July? How many more minutes did Janet use in July than in June? So in July she used 750. In June she used 525, so she used 225 more minutes in July than in June. Why could this graph be misleading? It's misleading because this looks like it's like 4 times bigger than this, but it's not. It's not even double. So the phone size is not proportional to the number of minutes used. So in conclusion, we found out the following information to be possible ways to mislead people using graphs and statistics. If they're using an average, look for outliers. This could mislead you to think the average is higher or lower than it really is. If there are outliers, don't use the mean, use the median for the measure of center. Intervals on a graph. Look for uneven intervals on a graph. If there are uneven intervals, it could be misleading. Graphs that don't start at 0 could make the data misleading. Also, pictures on graphs could be misleading. If you show a picture where the data is not proportional to the actual data size.